Welcome, everyone. My name is Allie. I am a writer for the user education team of the Broad's data sciences platform that developed Terra, and I'm going to talk today about what Terra is and how to use Terra for data discovery and access, in particular Anvil data. So today in this session, we're going to understand how the Terra platform fits into the Anvil ecosystem. I'm going to talk about what the components of Terra are and how you can use them for data consolidation, bulk analysis, interactive analysis, and also the built-in security aspects of the Terra platform. I'm going to talk briefly about the function of billing and permissions in Terra and authorization domains, and we will go over those in a walkthrough in a later session. So we spoke a little bit about the big data problem. Today we have vast collections of data, and they're getting bigger from individual labs, and they are hard. It's hard for researchers currently to take advantage of this wealth of data. How do you find and download the right data? What about if the format is different? How do you perform computations quickly, especially if you're not necessarily a programmer? And the third thing is data is getting too big to practically download and store. So the cloud has a solution to this, which is a different model of data. Traditionally, the individual researchers, such as yourself, would bring data to you. You might copy it to your own cloud or your local machine. The problems with that are data sharing is just data copying. It's getting someone else getting several copies. Each person works on their own copy. There's a lot of storage costs, especially as data gets bigger, and there's problems with individual security implementations. So the cloud way is a different way of thinking about data, and the idea is you have data in a public repository, and different researchers with the appropriate authorization can access the same data. You don't have problems with copying. It's true data sharing. It's instantaneous. And the centralized cloud repository can implement centralized security restrictions, as I'll show. So how do we make this happen? Quickly, managing data resources like this is part of a wider effort to build what we are calling the data biosphere. It started as an idea between friends of, instead of everyone building their own little walled garden, why don't we work together to build an ecosystem? It's an idea that's become a formal collaboration between these 5 institutions listed in the original article, and to build a modular system and environments according to common standards set by the Global Alliance for Genomics and Health, and using interoperable APIs and open source components. So let's dive in a little bit to what that means. How would a data biosphere be structured? So the vision is that there are four pillars or principles. One is that it's modular. Every piece has a particular function and a well-defined way to connect to the other pieces, makes it easier for them to work together and easier for people to extend them and add on. And I'll talk a little bit more about that later. It's community driven, so no one authority decides what's important to include and not include. When the basic foundation is open source code and open source platforms, it makes it possible for researchers who are involved to make changes that the broader community can use. The third point is part of that it's open. Open source means the components will be useful as possible to as many people as possible, and they allow the components to be reused and extended, and they allow users to add custom and proprietary modules as needed. And they're standards-based so that all the parts of the biosphere are consistent. They work well together. So how does that look like in practice? So Terra was designed for the data biosphere as a platform for research and analysis. It's meant to bridge the gap between data in the cloud, all these different resources, and end users, researchers, clinicians, and patients. With Terra, you have centralized access to these data sources and to tools like Jupyter Notebooks and workflows in the Broad Methods repository or in DocStore. And it allows you to pull from those open source resources and to use them in a single platform. So let's talk a little bit more about what that looks like. So Terra is meant to be an end-to-end cloud-native platform. In other words, it's a web-based application that you open in a Chrome browser, and it enables you to do all the aspects of your research project in one place. You can find and access data. That includes public access and restricted access data sets. We'll talk a little bit more about that. Lets you access the data securely and immediately, uses Google Groups and authorization domains as a means of controlling access, allows you to analyze. I'm going to talk about two different modes of analysis, workflows, which you can find on DocStore, and the Broad Methods repository, and interactive analysis. That includes Jupyter Notebooks and RStudio, and I believe we'll be expanding that repertoire, and allows you to share your work with other collaborators and to work together. So let's make this a little more concrete. How does Terra do all these different things? So it starts with a Terra workspace. You can think of a workspace as a sandbox, and generally you would have one consolidated workspace for a project. The landing page gives an overview of the project and the components you'll bring together. You can see here the documentation, which is in Markdown. And well done documentation allows your work to be reproducible because it explains how you did things, and it allows your collaborators to get up to speed quickly. There's also a place for data to keep track of all the project data, no matter what size and where it is, and I'm going to talk about how you can do that. There are two modes of analysis tools. There's notebooks for interactive analysis and workflows for bulk analysis. And then there's a job history, which allows you to monitor and troubleshoot your bulk analysis submissions, and we'll be talking a little bit more about all of these pieces. So we'll have a hands-on walkthrough later today, but this gives you an overall view of what it looks like. So you can think of the workspace as your place in the cloud. This illustrates how to think of it functionally. It has its own dedicated space with a data model, which is the tables that help you organize and keep track of the data that you need. And the data can be actually anywhere. It can be in your own workspace storage. It can also be in a different cloud bucket, like a Google bucket, in the case of the Anvil data, which we'll show, or it can be in the Terra data library, or you can bring your own. So it's pretty flexible. So what does the data piece look like for Anvil users? Currently, both the CCDG and CMG data sets for GSP members like yourself are made available as workspaces that are shared with the two different access lists. And here's a screenshot of a few of the restricted access Anvil data sets, which you'll be able to browse and export directly to your own workspace for analysis, and I'll talk about this later. Terra also has open access data sets, including 1,000 genomes, which you can find in the data library, and I'll talk about that when I do the walkthrough. So let's talk really quickly about what you can do with your data. So there's two different modes of computation. One is bulk analysis. This is how you typically do things like aligning reads. This is typically for genomic data, aligning reads or calling variants. And Terra does all the heavy lifting of managing the cloud resources to run these automated pipelines for processing in the cloud. So the idea is you configure it once and you run it as you need. And we'll talk about that. The second is interactive analysis, which helps you visualize and analyze your data. And it can be any size and it's in real time. And let's talk about a little bit more detail of bulk analysis. So there are a lot of bulk analysis tools available in Terra. You can also, as you see when you go to the Workflows tab, if your workspace has analysis tools in it, like this one does, they will be found in the Workflows tab, and there's also an option to find a workflow that you can then import into your workspace, and I'll go through that as well. So open, shareable, modular principles means, reiterating, you often don't have to write your code from scratch. Someone else has almost surely written a workflow that's very similar to what you used. You can go to DocStore, or Terra has some options for looking for things that are close to what you need or exactly what you need and running. And we'll talk about that when we do a run through. These are the sorts of analysis that you would do with bulk analysis tools, but it's not the only source of analysis. The second kind of analysis tool is an interactive analysis. I'm not sure how many of you have used Jupyter Notebooks before. Can we get a raise of hands and maybe okay. Couple. We are going to this afternoon go through a notebook, and there are some tutorial notebooks in Terra that I can point you to if you haven't used notebooks before. Notebooks are great for actually interacting with the data. So a notebook has documentation, again in Markdown, and code, and it lets you can run the code in real time to generate plots or to do statistics, and you're able to look at them to get a sense for what your data says. And again, we'll talk about that a little bit later. So you may be wondering, with such a comprehensive platform, how can I set up the computation environment and ensure that my collaborators and others can reproduce my analysis? Let's talk about containers. So containers are a way to understand computing environments that make it easier to set up standardized computing and ensure reproducibility. I'm sure many of you have had to work with the same data on more than one computer, and you run into problems with either the version of the software you're using or a dependency that is not copied. And containers solve a lot of these problems by taking the guesswork out of running workflows. The container contains all the software dependencies that you need for your analysis. And I will point those out when we are actually in the workspace. The nice thing about using a Docker container or a Docker image is that anyone using the image will get the same results. So if you want to test drive something on Terra, you want to get an idea of how to start, we have preloaded featured workspaces that showcase different workflows and Jupyter notebooks. And you can find them in the Showcase Workspace library, which I'll go through finding as well. Okay, how do you collaborate and share in Terra? So you're not doing Workspace in a vacuum. You need workspaces, you need other people to be working with you. And the workspace is shareable. So again, I'll show in the demo how you can share and you can copy workspaces, and you control how much access each of your collaborators has. They're private by default, and when you share, you determine if someone is reader, writer, or owner. And they have additional built-in security and privacy with authorization domains. So let's talk a little bit more about how Terra addresses security. So a few things to note. Terra is certified FISMA moderate. It leverages security with the Google security characteristics of the Google Cloud Platform, and it's FedRAMP for FedRAMP authorization. And it has a 15-minute timeout for clinical researchers, much like when you're on a bank site and website and you aren't working in it. It will time out so that people can't see the data. So the idea is that Terra configures workspace resources so that you can work in the cloud and not worry so much about management. And I'm going to talk in my next session a little bit more about security. We'll walk through that. So let's quickly talk about something that I'm sure is on all of your minds, which is cost. Workspace permissions also help you control access and billing. When you manage access by assigning permissions, permission resources include billing projects, which allow you to spend money on Terra, workspaces, which are assigned a billing project, and workflow collections. So roles include owners who can have admin privileges, writers, readers, can compute, affects cost, because if you share a workspace with something and give them can compute access, they can run up charges in that workspace. Writers are able to grant others writer access, and readers are only allowed to read the information in your workspace. We'll cover this again in the walkthrough, but now let's look through an example of how security works. So I'm going to talk a little bit about how sharing works and how it can lead to unauthorized access. So we're going to start with data, such as exactly like the Anvil data, which is kept securely in workspace number 1. So let's say it's cram files in the workspace bucket plus phenotypes in tables. Right now, user A is the owner of the workspace. And when user A shares with user B as a writer, user B can access the shared data as a writer, and user A's billing covers all the costs incurred in if user B or user A runs workflows in workspace number 1. Okay. Next, user B, who has writer permissions and can copy, makes a copy of the workspace and uses his workspace copy to run some workflows. In this case, I'm going to say that user B is going to run a variant analysis on the CRAMs and generate some VFC files. So user B is the owner and can share with user C. Now, when user B shares with user C, what happens? User C, who may or may not be intended to see the data, can now access the VCFs that were created out of the original CRAM files. So you can see this is a bit of a data security problem. So Terra has a means of protecting controlled access data. Terra uses authorization domains that enforce limits on data access. So An authorization domain is like a badge on the workspace that allows researchers with the same badge to access the workspace. When you clone a workspace with an authorization domain, the badge stays with the new copy, and anyone who wants to access the copy has to have the badge. So because authorization domains transfer automatically, you no longer need to worry about accidentally sharing sensitive data. If you try to share the cloned workspace with a user who doesn't have the right badge, that researcher won't be able to enter. In particular, about the key points are workspace access is only to users in the authorization domain. The authorization domain stays with the workspace and any copies, and it protects all data in the workspace: phenotypic data, derived data, and data from multiple sources. Okay, I'm going to show you an alternative scenario which demonstrates how authorization domains protect controlled access data. So very similar to the last time, user A sets up a workspace with shared data. However, this time, user A associates an authorization domain with the workspace. So when he shares with user B, who's also on the authorization domain, user B makes a copy, but now his copy also includes that authorization domain. And the authorization domain only allows user A and user B to access the data in workspace number 2. So user B cannot share with anyone outside the authorization domain. And that means that any new collaborators must be added in order to access the shared data or the original data. So a couple of pieces really quickly about instructions and caveats. First, authorization domains have to be set up before you create a workspace. You can't apply or change an authorization domain to an existing workspace. Since you have to create an authorization domain before you create the workspace, how do you do that? So it's very simple in Terra. The first thing is to create a group from the main menu in the top left. I'll go through this. And this is also where you can add members. This is this is a screenshot from the Terra. And then the second thing is to select the group as an authorization domain when you create a workspace. And we'll go through this as well. So you include all the collaborators that you want to share your data with, and a critical important part is that you can change the list. So if you can add people to the authorization domain, you can subtract people from the authorization domain, you just can't add or subtract an authorization domain. And again, it protects access to all the data, including derived files. So last piece I'm going to talk about how much Terra costs and how you pay. So Terra itself doesn't cost anything. The platform is free and open source. The idea is to enable scientists to get work done. There's a community of users and developers to help you. So you pay only for what you use. Costs can include storage, compute, and egress fees, but you pay only for what you use, which is a lot better than paying for resources you don't need. Even the Broad Genomics platform is moving in this direction. And you pay with billing accounts which are linked to Google Billing. And I'm going to cover this in the billing and authorization session in a little bit. Examples of billing accounts are institutional billing accounts, Strides billing accounts such as the Anvil uses, and free credits. Now that you know a little bit about Terra, you can spend your time doing science and not wrangling software. I have a couple of resources right here that I'll also talk in my later sessions. One is hands-on practice. These are really tutorials, so they're very step-by-step. They have step-by-step instructions to help walk you through how to run workflows, a bulk analysis, and how to run a interactive notebooks analysis. And you'll have these available on your copy of the slides. So I have 1 minute left. I will turn it back over to the moderators I know we're on a tight schedule.